Hey guys, it is week 6. We are covering lesson 94 for one day and then 95 and 96 for the other day. So just 3 lessons for the entire week. So let's go ahead and get over to lesson 94. So lesson 94, we're looking at probability of dependent events. Again, dependent means they depend on each other. What happened in event A does affect what happens in event B. So the probability experiments we've studied so far have been independent, like flipping a coin. You flip a coin, and you flip it again, it doesn't have any effect. The second flip is not affected by the first flip. Or rolling a dice. You roll a dice, land on a number, pick up, do it again. That second roll has nothing to do. So those are independent. We do have probability where it's dependent upon what happened in the prior event. So an event is a dependent event if the probability is influenced by a prior event. So if a marble is drawn out of a bag, mixed marbles, and is not replaced, then the probability for the next draw is different than it was for the first. Or a deck of cards. Pull a deck of cards, put it back in, shuffle it back up, and draw again. It's independent. You pull out a card and keep it out. That affects the probability of drawing a king or a queen or whatever on the next draw. So that would be dependent. So 2 red marbles, 3 white, and 4 blue are in the bag. If one marble is drawn and not replaced, and the second marble is drawn, what is the probability that both marbles will be red? So we want to first draw out what we know. And so we have red, white, blue. We're not given the total, but we can figure that out pretty easily. So that's 9. And so we're asked, what's the probability if one marble is drawn and not replaced, the second is drawn. So the first one, probability that it'll be red. Well, there's 2 out of 9. So 2 in 9 chance for event A. Okay, now, assuming we drew a red for event B, or our second draw, there's going to be 1, still 3 and 4. But now there's only 8 total marbles. So there's only a 1 in 8 chance of getting a red on the second one. Just like independent events, flip a coin, 1 and 2, flip it again, 1 and 2, 1 half times 1 half is 1/4. We still multiply. It's just not 2 ninths times 2 ninths. It's 2 ninths for event A times 1/8 for event B, and we get 2 goes into B, so we get 1 times 1 over 9 times 4. So 1 in 36 chance of doing this event A and event B. So we still multiply them together. It's just we got to pay attention that if we're replacing it, the probability stays the same. If we're not replacing it, and they're dependent events, that affects the probability of the second draw. Two cards are drawn from a regular shuffle deck. What is the probability of drawing 2 aces? Even though the cards are drawn simultaneously, so we think of it in terms of one event. We're not pulling one, replacing it, and then redrawing. So we're drawing 2 at the same time. But even though we don't pull one, look at it, and then pull another, it's still the same concept. So we have 4 aces out of 52 in a deck of cards. So we can reduce that down to 1 in 13. Now, the second card we're drawing at the same time, so there's really only 51 and only 3 aces left, so that reduces down to 1 in 17. So the probability of doing that is 1 times 1 is 1, obviously, and then 13 times 17 is 221. So there's a 1 in 221 chance of drawing 2 aces. That's not a very good chance. It's not 0, obviously, so it's still possible. It's just, remember, probability, it gets closer to 0, it's unlikely that's going to happen. Once it gets above 0.5 or 1/2 and closer to 1, it's getting a greater likelihood that it'll happen. All right, exponent key can help us out in this, and really all it's saying, so let's say we were looking at flipping a coin. And wanted so flipping a coin is a 1 and 2. But what's the probability of getting heads 10 times in a row? Well, we know it's a 1 in 2 chance, and we could sit there and go 1/2 times 1/2 times 1/2, or we could use our exponents. Since it's independent events and they're not changing, we can use this, and we get 1 in 2 to the power of 10. We have a 1 in 1024 chance of getting heads 10 times in a row, or tails. So the more events we have, the likelihood of it happening over and over and over again is going down. So that's something that can help us out. All right, lesson 95, we are looking at volumes of right solids. So again, we call these prisms, or if it's circular top and bottom, we call it a cylinder. So a right solid, meaning that the shape top and bottom are congruent. Rectangular prism, triangular prism, cylinder, as we mentioned, octagonal prism. Those are all examples. So in this one, again, the volume of the right solid equals the area of the base times the height. For like a rectangular prism, base area of a rectangle, length times width, and we multiply it by the height. Triangle, base times height divided by 2 times the height. So we've worked with the area formulas quite a bit. Volume, we're just adding in a third dimension that we need to multiply by. So then we have cubes, or if they're not perfectly square, it could be a rectangular prism, triangular prism, cylinder, and we call it by whatever the base is. So this is a triangular prism because we have a triangle here and then a triangle here, and they're congruent. Even if this, wedge or whatever fell on its side, that doesn't change it. It's still a triangular prism, just like this. If this were a coffee canister or a soup can or whatever, and it fell on its side, it's still a cylinder. So it doesn't matter the orientation that it's in, it's still triangular prism, or cylinder, or cube, or rectangular prism. So in looking at this, find the volume of the right triangular prism. Dimensions are in centimeters. We show 2 views of the prism. Again, it doesn't matter the orientation. This and this are the exact same thing. It's 3-dimensional. It doesn't matter how we move it. So we look at the triangle. We want to find the area of the triangle. We've done plenty of this. Base times height divided by 2. So 3 times 4 is 12, divided by 2 is 6. So that's the area of this. And then the distance between the 2 triangles, or what we call the height, is 6. So 6 times 6 is 36. Now we multiplied centimeters, so centimeters by centimeters, and then by centimeters. So 3 dimensions, we did 3 multiplications. That's where we get cubic units. Okay, so we don't just say 36. It's not 36. It's not 36 centimeters or square centimeters. It's 36 cubic centimeters. Okay, if we have this, the diameter of the right circular cylinder is 20 centimeters. Its height is 25. What's the volume? Let's see if we can draw this. Looks decent. So we're told that the diameter is 20, so the radius is going to be 10. So, and the height, height is 25 centimeters. The distance between these two circles is 25 centimeters. And we want to leave it in terms of pi. So let's just focus on the circle. Pi r squared. Pi r, the r is 10, radius 10 squared, so we get 100 pi. That's for this, and then we multiply it by the height, which is 25, so we get 2500 pi. And then it was centimeters, so 2500 pi cubic centimeters. Again, don't forget pi. This is different than 2500, 2500 times pi. So multiplying it by 22/7 or 3.14 or rational number, we're just going to leave it as that. So if Eric stores gardening tools in the shed with the dimensions shown, find the approximate volume of the shed. So again, this is 1, 2, 3, 4, 5 sides, so it's a pentagon, and it's not a regular pentagon, but we can break it apart just like we've done with finding the area of two-dimensional shapes that maybe aren't rectangles or triangles or things we're used to working with. We can do the same thing here. So let's look at this as a triangular prism. This is 8 feet, so this has to be 8 feet as well. So we're going to do 8 times 2, base times height, divided by 2, 16 divided by 2, which is 8. And then this distance is 10 feet, 2 inches, so we'll just call it 10 feet, because we're told we can approximate, so we can round. So we had what, 8 times 10, so that's 80 cubic feet for the triangular prism up here. And then this is an 8 by 7 rectangle. So 8 times 7, and then times 10 again. And so 8 times 7 is 56, times 10 is 560. See, the top part was 80. So 80 cubic feet plus 560 cubic feet is 640 cubic feet. Just like we did with polygons in the past, broken apart 2, 3, however many shapes we needed, so we can add the areas up. We can do the same thing with volume. We found the volume of this top portion and this bottom rectangular prism and added them together, and that's our volume. All right, we will do these together. The area formulas should be on your reference sheet, so definitely make sure that you hang on to those and don't lose that. Lesson 96, the last one for this week, we're estimating angle measures and the distributive property with algebraic terms. So if we're estimating, again, a clock is sometimes helpful to think of, a full circle is one full revolution, and we can think about, at your 2 o'clock or at your 6 o'clock or whatever. We've done this before. So we know that every 5 minutes we have a 1, 2, 3, 4, 5. So this is broken apart into 60 minutes, the clock. So 360 for one full revolution. Each tick mark at every minute, there's 60 of them, so 360 divided by 60. Each tick mark is 6 degrees. And that can kind of help us if we visualize that angle of whatever we're looking at. We can kind of picture it on the clock. That'll help us. So let's look at example 1, see if that helps us out. Estimate the measure of BOC. And we know DOA is 180 degrees. That can kind of help us out. So all of these angles have to add up to 180. So if this is our 12 o'clock and this is our minute hand or hour hand or whatever we want to picture it as, and it's not perfectly upright, but if we kind of mentally shifted it that way, it's not quite 90 degrees, maybe 80 degrees if we looked at it on the clock right here. It's not all the way to the 3, which would be 90 degrees. So maybe 72 degrees is what they estimate it as, 75, 80, whatever. And then this one will be much smaller. We know they have to add up to 180. So the measure of BOC, I was going to say maybe 80 degrees just in looking at it because it's not quite a right angle. They said 72. If we use a protractor, maybe get it to 75. And we're all hovering around the same answer. We only estimate when we're told to do so, otherwise we're going to be given enough information to calculate. Here's the distributive property. It's on your reference sheet and those things, so we've talked about this quite a bit. But if we have a number outside of a number or an unknown, outside of a binomial or even a trinomial or anything like that, if we can't perform the operation inside the parentheses, because we know grouping symbols and parentheses are what we do first, but if we're unable to do that, what we can do is we can distribute whatever is out here. So like in this example, A times B plus A times C, we can rewrite it as that. And when will this help us? Well, down the road, we'll do a lot of factoring and distribution, so we get comfortable with it. It'll really come in handy down the road. But if we're looking at our first example, sorry, I guess our second example, first example of this, we have 2x, 2 times x minus 3. Again, those parentheses, we can't do x minus 3. We don't know what that is, so we have to distribute. So we get 2 times x minus 2 times 3, which is 6. So pay attention to that negative sign. That's as far as we can go. It's not set equal to anything, so we're not solving for x. We're just rewriting it. Negative 2 times x plus 3. And this is example 2b. But distribute. Can't add because we don't know what x is. Again, so negative 2 times x plus negative 2 times 3 is negative 6. So we have negative 2x minus 6. Negative 2. Again, pay attention to the signs inside your parentheses and remember outside the parentheses because that's going to affect. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. And even if we have a variable outside, we can still distribute it. X times x is x squared. X times negative 3 is negative 3x. And that's as far as we can go. All right, so just working on distributing in that. Let's look at example 4. So we have x squared plus 2x minus 3 times parentheses x minus 2. Parentheses, first thing we need to do, but we can't do x minus 2 because we don't know what x is. But we can get rid of those parentheses by distributing. So minus 3x and then negative, this negative sign, negative 3 times negative 2 is positive 6. Haven't done anything with these terms out here. X squared, no other x squareds. So that one just remains. 2x minus 3x, okay, they both have x to the same value. I can combine those. 2 minus 3 is negative 1x, or just negative x. No other constants, so that just remains as plus 6. All right, that is it for this week, those 3 lessons. We'll see you in class.